Hi, and welcome to our Week 3 class. In today's lecture, I wanted to spend some time on the topics of regular expressions, as well as JSON and XML. And by the end of this video, you will be more comfortable with these topics because I will share several examples. Now, one of our weekly assignments is also about regular expressions, and I will cover it for you as well, while the second assignment is about both JSON and XML. Also, due this week is a mid-semester survey. Please take a few minutes of your time to complete it, and please be as candid as you can. We value this feedback and use it to help improve our classes based on what you tell us. So please let us know what you think. Alright, so let's get started, and I'll dive first into regular expression. So regular expressions, commonly known as Regex, are powerful tools used for matching patterns within strings. They allow us to search for specific sequences of characters and can be used for a variety of tasks such as validation, searching, replacing text, processing text, and data extraction. Now, at the core of regular expressions are literal characters and meta characters. Literal characters match exactly what you type, such as the letter A matching the character A. And meta characters, on the other hand, have special meanings. For example, the dot meta character matches any character except the new line. And here are some of the most common meta characters used in Regex. Again, the dot matches any character except a new line. The caret asserts the position at the start of a string, and the $sign asserts the position at the end of a string. The square brackets are used to define a set of characters, and the star, plus, and question mark are used to specify repetitions. As for the backslash, it's used to escape special characters when you want to use them as literal characters. And please don't worry if this is not making much sense yet, but it will when you see the code examples throughout this video. Okay, now in Python, we use the RE module to work with regular expressions. This module is part of the Python standard library, so you don't need to install it. But you do need to import it in your code to use it. And once imported, you gain access to several functions, with the most common ones being re.match, re.search, re.findAll, and re.sub. The match function matches the pattern only at the beginning of the string. The search function searches for the first occurrence of a pattern anywhere in the string. The findAll function finds all the occurrences of a pattern in the string, and the sub function finds all occurrences of a pattern and replaces it. Alright, let's look at a code example using the match function. This function only matches patterns at the beginning of the string. Here we import the RA module and define a variable called pattern, and assign it a string value of hello. This is the sequence of characters that I'm trying to match against or find in my string. And what is that string? Well, that's my next line of code. We define a text string with value hello world. So basically, I want to find this pattern in this text. And how do I do that? Well, I use the match function of my RE module. Now, the match function takes 3 arguments: pattern, string, and flags. But flags is optional, so I don't have it here. Now, using the match function of the RE module, I will pass these 2 arguments to check if the pattern matches at the argy matches at the start of the text. And the function will return a match object if the pattern is indeed found at the beginning of the string, which we print out in our last line of code to see the result. But if there is no match, then Python just returns the word none. So let's see this code in action. Here we go, and now let's run it. What I get back is a successful match result. I basically get a match object. I also get where it was found in my string, and I get what the match was on. Now let's go back to my code, and I'll change my pattern to anything that I know does not match. And let's run it again. I get the word none, which means that my pattern was not found at the beginning of my string. Let's go back to my code once again. Now, I also mentioned the optional flags argument, which is the 3rd argument in the match method. One of the ways to use the flags argument is to set its value equal to the ignore case value You see, Python is a case-sensitive language, so if I change my pattern value to hello with a capital H and run it again, I get a none value due to the case sensitivity. But if I don't care about the case of the letters, then I want to ignore this issue. So I'll return to my code. I can now add my flags argument and set it equal to re.ignoreCase. And now when I run it again, I get a match this time. And there's actually a shorthand for this flag option. So let me go back to code once more. I can just replace ignoreCase with just a capital I, and when I run it again now, it still works, and I get a match. All right then, let's move on and take a look at an example using the search function. Here we start by importing the ERE module and define a pattern variable with a string value of world. We then define a text string and give it the value hello world. And very similar to the match function, we call the search function and pass it two arguments, pattern and text, because we want to search for the pattern in the text. Once we run it, the function will return a match object if the pattern is found, or return none if nothing is matched. So let's see this code in action. Here we go. And now let's run it. I get a match object, and I also get where it was found in my string. And I get what the match was on. Now, let's go back to my code. And if I change my pattern to anything that I know does not match, and run it again, I get the word none, which means that my pattern was not found anywhere in my string. Okay, let's move on to our next common function in the Regex module, and that is the findAll function. As the name implies, this function returns all matches of the pattern in the string, and it returns these matched values as a list. Now in this code example, we use the pattern \, followed by a lower d letter, followed by a plus sign, and we already learned that the plus sign in Regex means for something to appear at least one or more times. But what about the \d? Well, in the Regex world, this is the pattern to match any single digit from 0 through 9. So, when we combine \d with the plus sign, we are basically creating a pattern that includes any single digit that appears at least once and can be followed by unlimited number of digits. But wait a minute, what is the R letter before the double quotes? In general, the R letter before a string in Python denotes a raw string. Raw strings are used to treat backslashes as literal characters rather than escape characters. This is particularly useful when working with regular expressions because regular expressions often contain many backslashes. And in this particular example of the R letter preceding the pattern string of \d plus, here the \d is interpreted as a literal backslash followed by d, which is a meta character in Regex representing any digit. As for the plus character, this means one or more of the preceding element. So this full Regex pattern matches one or more digits. Now to find all occurrences of one or more digits in the text variable, there are 12 apples and 34 oranges. I use the Regex findAll function. This returns a list of all matches, which we print on the next line to see the results. This should output a list containing 12 and 34, because these are what match my Regex pattern. So let's see this code in action. Here we go. And now let's run it. As expected, I get back a list of these two numbers. Now, let's look at an example using the sub function, which is used for substitution. In this example, we define a pattern variable and set it equal to apples and a replacement string bananas. And my text string that I want to match the pattern against is I have apples and more apples. Then, on the next line of code, I use the sub function and pass it 3 arguments, pattern, replacement, and text. What this will do is try to match my defined pattern in my text variable. And if there's a match, then it will replace all occurrences of apples with bananas. And the result is the modified string, which we print out to see the changes. So in this particular case, the expected output should be, I have bananas and more bananas, since I'm replacing apples with bananas. So let's see this code in action. Here we go. And now let's run this code. As expected, apples have been replaced with bananas. Now a couple of things about the subfunction. Notice how that all the matched occurrences have been replaced, right? Well, there's an optional argument we can pass to the subfunction to control how many matched instances we want to replace, and that is the count argument. So if I go back to my code, then modify my code by adding the count argument and set it equal to 1, then only the first matched instance of the pattern should be replaced. So let's run this code and see what happens. There you go, only the first matched occurrence is replaced. So now we see that with optional arguments, we can have more control over the behavior of our functions. And to get the full whole story on each and every function, please do refer back to the actual Python documentation. Now, in my humble opinion, regular expressions are incredibly powerful for text processing and data extraction, and mastery of regex comes with practice. So don't hesitate to experiment with different patterns and test them out. Python's RE module provides all the necessary functions to perform regex operations effectively and with little lines of code. Okay, I'll switch now to a few more code examples and run through them quickly, just to give you some more practice. So in this first code example, we are going to search for certain patterns that we can enter ourselves and match them against strings in a text file. This is very common to do in our daily work where we need to do a find on some text in a file. So this code has some explanatory comments at the very top with what regex patterns to enter and what the expected output should be. Then we have our code. We start out by importing the RE module. I define and set a count variable and set its value equal to 0. I open a text file that I will use to match my pattern against. And here is the text file. You can see it's full of text, and if I do a search on the word author, I get a few hits. But the question is, how many exactly? Well, that's what my regex code will do for us. So back to our code. Now, instead of hard coding the pattern to search for, I'll prompt the user to enter their own regex pattern. Then I'll loop through the text file we saw a moment ago and go through it line by line using the for loop. And if a match is found, then I'll increment my count variable by 1. Then when the loop is done, I'll print out a line that says, the mbox.txt file had count lines that matched whatever pattern I entered. So, per the comments above, I'll test this code by finding any lines that start with the word author and any lines that end with the word Java. And we already learned that the caret character before the text in regex lingo means starts with, and the $ character after the text means ends with. And let's run this code to verify this is what will happen. Okay, I'm prompted to enter some regular expression, so I'll type caret followed by the word author. What this will do is loop through the text file, line by line, to see if the line starts with the word author, with a capital A, because regex is case sensitive. And when I hit enter, I get that we found 1,797 occurrences of the word author at the beginning of the line. So pretty powerful stuff with just a few lines of code. And if I go back to my code and run it again, this time I will enter the word Java followed by a $sign. This is the pattern I want to search for or match against, which means find me any line in my text file that ends with the word Java. And now I'll hit enter. I get that we found 4,218 occurrences of the word Java at the end of line. Let's move on to another regex code example. Here we are creating a function to match a word that contains the letter Z. So nothing in this code is new to us. We start by importing the RE module. In my function, I create a pattern of lowercase z followed by the plus character. And in regex lingo, this means to find any instance of the letter Z that appears at least once. Then I use the findAll function to see if this pattern was found in my SomeValue argument. and this value argument is what gets passed to my match z function through the function call down here. And if a match is found, I will print out found a match. But if not, then print out not matched. And in my first function call, I have the word pizza as my argument. So this should find a match because the pattern says to match at least one letter Z. And when I run this code to verify the behavior, I get a match as expected. And if I go back to my code again and change pizza to burger, then run it, I get no match because we were unable to match the pattern to the word burger. Okay, let's do one more code example on Regex. Here we are trying to find all words in a string which are at least 6 characters, long and starts with a capital A or small a. So these are the requirements here. And we even have a string sample to use. Now, the tricky part in this code is just the pattern to use that will match the requirements of this problem. And I solved it by using this regex pattern. The square brackets with a capital A or lower a means that we are matching against any of these letters. Then the backslash W means any word character, which means any word character, which means any alphanumeric character. So it can be letters, numbers, regardless of case, plus an underscore. Then I follow it with braces, and inside the braces I have a starting point and an ending point. So since I want to find words that are at least 6 characters, but I already have the starting letter, which is the A character, then I just need to follow it by 5 characters. As for the ending part, well, I left it blank after the comma because the requirements called for at 6 or more characters. So the value in the braces can be a single digit, which would indicate an exact number of repetitions. Or it can be 2 digits separated by a comma, where the first digit is the starting count and the second digit is the stopping count. And if you don't include a stopping number, then it's an open number, so no end limit. Then I call the findAll function and pass the pattern and string arguments. So in this string, I want to find any text that starts with the letter A, regardless of case, and be at least 6 characters or more. And when I review the S variable, I see that my first A character is here, but it's not followed by at least 5 more characters because the space breaks that rule. And my next A character is here, and I do see that it is followed by at least 5 characters. So this fits the bill and should register a match. Then the next occurrence of A is the last word in our string, and it also has at least 5 characters after the A, for a total of at least 6 characters. So let's run this code. And I get a list of 2 matched strings as expected. But let's go back to our code and try to modify the string value to break the match. For my last word, I'll remove 3 characters. This will not create a match for that particular word because while there's an A letter, it doesn't meet the minimum of 6 characters. So let's run this code. And now I only get 1 matched instance of our pattern. Alright, now it's time to review our assignment. It's basically asking us to create a regular expression in Python to validate email addresses and phone numbers. The steps are to create a Python file called regex.py, import the RE module, and then create a function called validate_email and another function called validate_phone_number. The requirements for the validate email function is to take an email address string as an argument and use a regular expression to check if the email address is valid. If it is, then return the word true, but if not, then return false. As for the phone number function, we take a phone number string as an argument, use a regular expression to check if the phone number is a valid US phone number, and return true or false accordingly. Now the requirements for what constitutes a valid email or phone number are listed below in Resource 1. A valid email address starts with one or more lowercase letters or numbers, optionally followed by a period or underscore, followed by more lowercase letters or numbers, then followed by the @ symbol, then followed by the @ symbol, then followed by more alphanumeric characters, then a period, and finally 2 or 3 more alphanumeric characters. So that's what we need to build our regex pattern on. As for the phone number, it needs to be in the format of 3 digits, then a dash, then 3 more digits, then a dash, then 4 more digits, and the first 3 digits can be surrounded by parentheses, but that's optional. The first 3 digits can also be followed by a dash or a space. So these are the requirements, and of course we need to test our code multiple times using different emails and phone numbers to verify that all works well. Okay, I'll take you to my version of the solution. Here we go. I start by including a string literal of the requirements, which is an easy way for me to look at as I build my regex pattern. Now you are familiar with all the code in front of us here, but the most important part is this pattern variable, and that's what I want to explain to you. So I'll break it up step by step by step. First, the requirements say an email starts with. So I need to use the caret symbol. Then it says that it starts with one or more lowercase letters or numbers. In regex lingo, that would be a set of characters. So I use the square brackets to signify what's accepted, and then inside the brackets I provide the accepted characters. In this case, the lowercase letters would be the set of A-Z, which mean all letters from A to Z. And for the set of numbers, it would be 0-9, which include all numbers from 0 to 9. Now, I include a plus sign right after the closing bracket, which would allow for one or more of these A to Z and 0 to 9 characters. Then the requirements call for an optional period or underscore. So I include these 2 characters next as a set to choose from, which means I surround them with a square bracket. I then follow it by a star character, which means it can appear 0 or more times. In other words, it's optional. So in general, anytime you hear the term optional, then use a star character. Then the requirements call for more lowercase letters or numbers, which we now know how to do. And that is the brackets with a 2Z and 0 to 9 followed by a plus sign. Then the requirements say to follow it with an @ sign, so we just type that as is. Then followed by more alphanumeric characters, but because it doesn't specify upper or lowercase, we must include both the A to Z in upper and lowercase sets. And please don't forget the plus sign right after the closing bracket to indicate at least one or more characters. Then we need a period, which will be the start of the .com or .dot, whatever domain is used in the email. But since the period or the dot character has a special meaning in regex, which is a pattern to match any character, and that is not what we want here, then I need to escape that period character by placing a / character before the period. This will tell the regex engine that this is just a regular period and not the regex special character. Then the last piece of the pattern after the period are 2 to 3 more alphanumeric characters. And to create that pattern, in regex, we do the braces, or sometimes called squiggly brackets. And inside, we use the start length of 2 and end length of 3, and we wrap it up with a $sign because that's how we want to end our pattern, with 2 or 3 characters in length after the period. So to sum up that pattern once again, a valid email should start with any set of 1 or more characters from the set of lowercase letters and numbers, followed by an optional period or underscore, followed by 1 or more lowercase letters or numbers, followed by an @ sign, followed by 1 or more lowercase or uppercase letter and or number, followed by a period, followed by the end by 2 or 3 characters of upper or lowercase letters and or numbers. Wow, that was a lot to say, right? And now, the moment of truth. Let's test this out and see if it behaves correctly. So down here, I have an email variable where I type my email value. I first have a test email that should meet the requirements of my regex pattern. It's just abc@abc.com. Then I call my validate email function and pass it my argument that has my email string. So I'll run my code now, and I found a match. So our code seems to be working fine so far. But wait, we need to keep testing and verifying. So I'll go back to my code. And let's change our email some more. I'll try abc123@abc.com. I'll run it again. Good. That also worked, which is expected. Now, let's go back to the code and let's try some failed email addresses. So abc!@abc.com. Now this should fail because the email should only start with lowercase letters and numbers. An exclamation mark is none of these. Let's run this code. And yes, it fails correctly. Let's go back to the code again, and let's try adding a fourth character to .com. Remember, it can only be 2 or 3 characters long. So here's any random fourth character. Let's run this code. And it fails again, as expected, because now my email does not end with the allowed 2 or 3 characters. But let's go back again to the code. And if I change the domain part to just .us, this should work because 2 characters are allowed. So let's run this code and see. Yes, found a match. Now just a word to the wise. Regex can be written in different ways to get the same result, and this will become easier the more you play with it. I look at Regex as a mini programming language. Each character and symbol means something, and we need to know those meanings in order to use them in the right places at the right time. So it's another syntax. At first, Regex is a pain, but once you get good at it, you will realize how much of a blessing it is. Please trust me on this. Okay, so now that we completed the first half of this assignment, let me go back to my code again to complete the second half of the assignment. I will comment out the email portion of this code. Then I'll uncomment the code at the bottom, which is the part for the phone number. This code basically imports the Regex module. Then we create this complicated looking pattern, which I'll explain in a moment. Then, this time I lump all the different phone numbers into one list. As you can see, this list contains some well-formatted numbers along with some poorly formatted numbers. Then I have a for loop to check each number in my list against my Regex pattern. But there is a small difference in this code here. Instead of using the findAll function, I'm using the search function. Actually, I still could have used the findAll function, or even the match function. So why don't you try to figure out why all 3 functions would work, and which function of the 3 would make sense to use in this particular problem? Please tell me in the comments below. Alright, so the assignment is asking us to find valid phone numbers. And a valid US phone number is in the format 3 digits, followed by 3 digits, followed by 4 digits. The string should start with either a 3-digit number enclosed in parentheses, or just a 3-digit number, optionally followed by a dash or space, then another 3-digit number, and another optional dash or space, and finally a 4-digit number. So that's what constitutes a valid phone number. Next, let's examine what I came up with for Regex pattern. I start with the caret symbol because I'm checking from the very beginning of my text. Then let me highlight the first set of parentheses. The opening and closing parentheses help to group what's inside, and they are not the parentheses we use in the actual value of the number. Actually, the parentheses that surround the area code, that is what comes next. Here I have a backslash, which is the Regex escape character, followed by an opening parenthesis. I need to do that because the open parenthesis is also a special character in Regex, but I don't want to use it here as a special character. I just want to use it as an actual string character. Then I follow it with a \d, then braces with a 3 inside. This means exactly 3 digits, no more, no less. Then I follow it with another escape character, the \, and then a closing parenthesis. This is the actual closing parenthesis of the area code. Then I have a pipe symbol. This means a logical OR behavior. Then I follow it with the same \d, then braces with 3 in it. So what this is saying is to match any 3 digits as a stand-alone group, or surrounded by parenthesis. Next, we have a second group, which is an optional dash, or space. The \ followed by the letter S is regex for a space character. Then following the brackets, we have a star character, which means the dash and space are optional. So they can appear 0 or more times. Next, we have a \d, which means a digit, but we want 3 digits, so we follow it with the number 3, surrounded by braces. Then we have once again the optional dash or space. And we end it off with 4 digits, as can be seen by \d, 4 in braces, and the $sign. So this should be sufficient to meet our requirements. Now let's review the provided list of numbers. The first 5 numbers should work as they meet the regex pattern. But last 5 numbers should fail because each has something wrong with it that doesn't meet the regex pattern. For example, the first one has only 2 digits in the first group, but we are expecting 3 digits in the first group. The second phone number also only has 2 digits in the second group as well. The third phone number has 3 digits instead of 4 in the last grouping. The fourth phone number has a letter in the first grouping, but we only accept digits, not letters. And the last number has a space in the first grouping. So it seems that the first 5 numbers are valid phone numbers, while the last 5 are not valid. And again, we must verify that this works. So let's run this code now. Okay, so this is valid, this is valid, this is valid, this is valid, and this is also valid. Great. Then the remaining numbers are not valid, as expected. So it looks like our code runs correctly, and our regex pattern is correct. Alright, this wraps up the regex part for this week. I hope it was helpful, and if you have any questions, please email me at any time. Thanks for watching. Take care and bye for now.